Okay, question number 16, last one from the review packet. I want to work on this one. Just kind of go ahead and I already have a sketch sort of drawn up here to represent the problem. I will read the problem out loud. You probably can just follow along to see what's going on the review sheet. This says Maddie and Clyde currently have a larger circular farm. The farm was built around an apple tree at a coordinate of 10, -7 and has a gate located at a coordinate 18, -1. They wish to downsize their farm with a 2:3 ratio that will still use the gate located at the coordinate 18, -1. Using transformations and ratios, find the new equation of a circle in order for them to build a new fence. Okay, so what's going on is they have this large circular farm that was originally built around an apple tree with coordinates of 10, -7. And it said there's a gate located at coordinates of 18, -1. So this is the gate. Oops, we got it here. So we've got the gate at 18, -1, and then we have a tree located at our coordinates of 10, -7. Okay, so here's the tree out here. But their goal is to simply downsize. Okay, so this farm is just too big, and so what they're going to do is they want to keep the gate. They're not concerned with having the farm still centered around the tree, but they do want to keep the gate at the edge of the fence. So they don't have to build a new gate, and so what they're going to do is they want to downsize it with a 2:3 ratio. Okay, I'll write this over here. Oops, 2:3 ratio. And that 2:3 ratio is going to be still using the gate. So in other words, if we're thinking about a directed line segment here, that means we're going from the gate to the tree in a 2:3 ratio. Right? So what that means is if I was to look at this line, it kind of got a little off kilter there. Let me back up just a little bit, straighten that out. So if I'm looking at this line right here, then I want to partition this so that I have a point with a 2:3 ratio somewhere out in here, and that's going to be the new center of the lot. Okay, so the lot's going to be quite a bit smaller. If you would imagine it, that's going to be the new center, and we would have a circular lot coming around there. Okay, and that's not obviously really a circle, but you get the idea. So it is a much smaller lot. Now let me just try and clear as much of this off as possible and erase that, because we are going to need to write on the sketch here. So if you haven't done the sketch, if you want to just pause the video for a minute and sort of make this same type of sketch, you're welcome to do so. It may help you out as you visualize this, because you'll definitely want to do this as you work on the problems for the actual test if you see a problem similar to this gate problem. Okay? So what we're going to do is we first need to figure out the center of these coordinates of the new lot, and to do that, that is the partition point. And if you remember, one of the other targets was about how to partition a line segment, and so we've had a good bit of practice at this. Hopefully you'll remember how this works. So one of the easiest ways we've talked about doing this is to simply figure out the height and the width of the triangle that's made with this line segment here. So if we look at the width, we're going from an x value of 10 to 18. So that means the width of this triangle is 8. If I look at the height, it's from -1 to -7. That is a height of 6. Oops, got a little off kilter there. That's a height of 6. Right? Now, if we look at this ratio, 2:3, that is a total 2 parts and 3 parts of 5 parts, not 6 parts. Again, the pen got away from me. 5 parts. And so if we're thinking about this in terms of ratio, that means if my ratio is 2:3, that I'm putting my point about 2/5 of the way down this line. And to figure out where that's actually located, that simply means we need to go down 2/5 of the height, which would be 2/5 of 6. And then we need to go to the left, and I'm going to just draw it going to the left from this point. Obviously, we would be going to the left from somewhere up in here. And we need to go that way 2/5 of the width, which was, in fact, 8. Okay, so if I start at the gate, go down 2/5 of 6, and to the left 2/5 of 8, that should give me the coordinates of the new point. So we just simply need to figure out how far this is. If you, again, if you have a calculator, this is very simple. Just do 2/5 times 6. And if you do that, that gives you 12/5 or 2.4. So that's how far we need to go down from our gate. And then if I do 2/5 of 8, that gives me 16/5, which translates to 3.2. That's how far I need to go to the left of the gate. Okay? So if you imagine we're starting here at the gate, coming down 2.4 and going to the left 3.2, and that will put us at our partitioning point. So I'm just going to draw a little sketch of this point right here. So let's say this is the gate at 18, -1. If I go down 2.4, that puts me at a coordinate of 18. Again, if I'm just going straight down, same x value, but my y would drop 2.4 to -3.4. Okay, and then I need to go left by a value of 3.2, and so that's actually going to be taken away from the x value. If we start at 18 and we go to the left 3.2, that's just taking that away, and we end up with an x value of 14.8, and our y is still -3.4. So that means these are the coordinates for the new center of the circle. Okay, and I'll just call that C. So the new center is at 14.8, -3.4, no longer centered at the tree. All right. So the gate is on the edge of the circle. This would be the center. So now the only other thing I need to know besides the center is the radius, and then I can actually write the equation. So this radius, we can just use Pythagorean theorem. If you do 2.4 squared plus, so let me, just to make sure it's clear that that is the radius, imagine this is the center, this is on the edge of the circle. So in fact the circle is coming around something like this. All right. So if we're trying to find this, again, we just made a little triangle here, so I just used the height and the width, 2.4 squared plus 3.2 squared, and that equals the c squared, or excuse me, the radius squared. So if I was to plug this in my calculator, what you end up figuring out is that r squared will be equal to 16. So we take the square root of both sides, and we get that the radius is in fact equal to 4. So to write the equation for the new farm circle, again, they're trying to build a fence, so they're just coming up with an equation to represent where the fence will actually be located. And the equation for that circle is x minus the x value of the center, 14.8, and square that, and add to that y minus -3.4, and if you subtract negative, that's the same as adding, so I'm going to change that to y plus 3.4 squared, and all that has to equal the radius squared. The radius was 4, so 4 squared is 16. So that means this is the new equation for the circle with the new center and radius. All right. So hopefully that helped. If you would like to see any additional practice of this type of problem, please leave a comment on the video or send an email to me. You can send it to mrwootenmath@gmail.com, and I'll be glad to try and post another video just so you can see a little bit more practice. Okay, but make sure you go back through, try this out, work it out, make sure you have it drawn on paper, just so you got the habit of seeing actually how to work this out step by step, and hopefully that gives you a good idea of what you need to do to solve a problem like this if you should see it on the test. All right? And that wraps up the review. If you're looking for other particular problems that haven't been posted yet, please just sort of check back in periodically tonight, and there should be a few more problems popping up. If you would like to see any other questions in particular, please also leave a comment so I can know which problems you would like to see the most, and I'll try and get those up as quick as possible. Alright, so good luck studying, and hope you do well on your test.